Microbiology It by committing to memory your micro mind map. Review it while watching this video and answer the problems at the end. And don't forget to download your Microbiology It workbook. The link is in the description box. Waterborne diseases often come down to a simple pattern. An environmental source becomes contaminated. A pathogen enters the body through food or water, and the infection unfolds quickly if the host doesn't intervene. Cholera is a classic example. After someone consumes water or raw seafood contaminated with Vibrio cholerae, the bacteria move straight to the small intestine attached to the epithelial lining and release cholera toxin. Now, this toxin doesn't destroy tissue, it hijacks ion transport, causing the body to flush massive amounts of water into the gut. That's why cholera leads to sudden, severe diarrhea and life threatening dehydration. In many regions, mortality isn't driven by the bacteria themselves, but by the lack of rapid access to rehydration therapy. Simple solutions containing glucose, salts, and bicarbonates save lives because they restore the ions that toxins force out of the body. Legionellosis tells a different kind of story, one rooted in modern infrastructure rather than contaminated food. Legionella pneumophila thrives in warm water systems, especially where biofilms form in pipes, cooling towers, spas, or air conditioning units that aren't properly maintained. When the water becomes aerosolized, people inhale tiny droplets carrying the bacteria. Unlike cholera, Legionella targets the lungs. It grows within macrophages, slowly building an infection that can look like a mild flu at first, especially in healthy individuals. But in older adults or people with compromised immunity, that mild infection can progress into severe pneumonia. Because the bacterium is resistant to typical chlorination and heating methods, control relies heavily on proper facility maintenance, hyperchlorination, or raising system temperature to levels that kill the organism. Typhoid fever adds another layer, reflecting the global impact of poor sanitation. Caused by Salmonella enterica cerevisiae typhi, this infection spreads where sewage contaminates drinking water, a problem still common in parts of sub Saharan Africa, the Indian subcontinent, and Southeast Asia. Once ingested, the pathogen moves beyond the gut, entering the lymphatic system and bloodstream, leading to the systemic infection. The progression is gradual mild fever in week 1, high sustained fever and abdominal pain by week 3, and potential dangerous complications like intestinal perforation or septic shock if untreated. Historical cases like Typhoid Mary highlight how asymptomatic carriers can unknowingly perpetuate transmission, especially in food handling roles. Antibiotics dramatically improves outcomes today, but prevention still relies on clean water and effective sanitation systems. Noroviruses, on the other hand, is the great equalizer. It spreads rapidly in households, dorms, cruise ships, and anywhere people share food or tight spaces. This virus is a highly contagious plus sense RNA virus that causes acute gastrointestinal illness. Symptoms come on fast vomiting, diarrhea, and fatigue that make it hard to function for a day or two. While most people recover quickly, the illness can be dangerous for infants and the elderly and immunocompromised individuals because dehydration sets on easily. Diagnosis usually depends on symptoms, but labs can use RT PCR to confirm viral RNA when needed. Norovirus spreads through the fecal oral route, often via contaminated spaces, person to person contact, or water sources like wells or recreational water exposed to sewage. Because it takes only a few viral particles to cause infection, outbreaks are hard to contain without strict hygiene and proper disinfection.